All right, welcome to the Explainer. Today we're diving into a really powerful tool in the Java world, something called Hibernate. It tackles a super common and honestly a very tricky problem. We're going to follow the journey of a single piece of data, from just a simple object in your code all the way to a secure record in a database, and see how this framework makes it all happen.
Okay, so let's get right into it. To really get why Hibernate is such a big deal, you first have to understand the problem it was designed to solve. I mean, saving data. Sounds simple enough, right? But when you're actually working with modern programming languages and databases, there's this fundamental disconnect.
And this right here, this perfectly shows that disconnect. It's actually got a name, the object relational mismatch. Think about it. On one side, you've got your Java code, where we think in terms of these flexible, interconnected objects. But then on the other side, your database, it thinks in these rigid, structured tables, rows and columns. They just don't speak the same language. And trust me, writing all the code to manually translate between them over and over again, it's not just tedious, it's a massive source of bugs.
So this is where Hibernate swoops in to save the day. It's an object relational mapping framework, or ORM for short. The best way to think of it is as this incredibly smart, super efficient translator. You just get to work with your Java objects like you normally would, and Hibernate handles all the messy, complex work of figuring out how to save them, how to get them back, and how to update them. It all just happens behind the scenes.
Okay, but for this translator to do its job, it needs some instructions, right? It needs a dictionary, a blueprint, something that tells it exactly how, say, a user object in your code connects to a users table in the database. And this whole process, it's called mapping.
Now, back in the day, in the early days of Hibernate, this mapping was all done using these separate XML files. And look, it worked, but it also meant your application's logic was split up across all these different files, and things could get, well, pretty complicated pretty fast.
So just for one single user object, you had to deal with the Java file itself, a totally separate mapping file for Hibernate, and a main configuration file. Like I said, it got the job done, but wow, is it clunky. It just spread your core logic all over the project.
Thankfully, things have gotten so much better. The modern way to do this is with something called Java annotations. So instead of having all these separate files, the mapping information lives right inside your Java code. It is so much cleaner and way easier to follow.
So, how does this actually work? Well, it's pretty simple. It all starts by adding this little thing, @entity. It's an annotation you put right above your class definition. That's it. Think of it like you're planting a flag. You're telling Hibernate, hey, pay attention to this class. This is one you need to manage and know how to save.
Okay, next up. What if your class name doesn't perfectly match your table name in the database? No problem. You just use the @table annotation to be super clear about it. Here, we're explicitly telling Hibernate, look, my user class goes into the users table. Simple, no guesswork involved. And this is a big one. Every record in a database needs a unique identifier, right? A primary key. So in our code, we just mark whatever field that is with the @id annotation. And even better, by adding @generated_valued, we're basically telling Hibernate, hey, let the database worry about creating this ID for me. Our code doesn't have to touch it. It's fantastic. So when you put it all together side by side like this, the benefits are just crystal clear. With annotations, everything is self-contained right there in your Java file. It's way easier to maintain. And maybe the best part? Because it's actual Java code, the compiler, your development environment, can catch mistakes for you before you even run anything. That is a huge advantage over finding some tiny typo in an XML file when your application crashes at runtime. Okay, so we've given Hibernate its map. Now let's actually follow a user object on its journey. You see, any object that Hibernate manages exists in one of 4 very distinct states. And really understanding this life cycle, this is the key to using Hibernate well. So our little data object goes on this journey through these 4 key states. It starts out as just a plain old object in our code, then it becomes actively managed by Hibernate. After that, it can be detached from Hibernate once it's saved, and finally, it can be marked for removal. Let's break down each one.
All right, first up is the transient state. This is where everything begins. As soon as you type new user dot in your code, boom, you got a transient object. It's just there. It exists in your application's memory. But here's the key. Hibernate knows nothing about it yet, and there's definitely no row for it in the database.
Now, this is where the magic starts. When you take that transient object and you pass it to a method like session.save, it officially transitions into the persistent state. Now it's under Hibernate's direct management. It's connected to an active session, and any change you make to that object, say you update the user's name, Hibernate sees it, it tracks it, and it will automatically save that change to the database when the whole operation is done.
So, what happens after the operation is finished and the session is closed? Well, the object enters the detached state. The object itself still exists in your application's memory, and its data is safe and sound in the database. But, and this is important, Hibernate is no longer actively watching it. It's like Hibernate has said, okay, my job here is done. If you modify that object now, nothing will happen automatically. Those changes are not being tracked.
And finally, we have the removed state. If you take an object that's currently being managed, a persistent object, and you pass it to session.delete, it enters this state. Now, it's still hanging around in memory for a little bit, but it's been officially marked for deletion. As soon as that transaction commits, Hibernate sends the final command to the database to remove that corresponding row for good.
Okay, this is a super common point of confusion for folks. When retrieving data, should you use get or load? The rule of thumb is actually pretty simple. Use get when you're not 100% sure the data actually exists. It'll go to the database immediately, and if it doesn't find anything, it just gives you back null. Easy. But if you are confident the record is there, use load. It's a bit of a performance trick. It's faster at first because it just gives you a placeholder, a proxy, and it only actually hits the database if and when you try to use the data from that object. So you might be thinking, Hibernate is just about moving data around, but it does so much more than that. It actually adds these really powerful layers of intelligence and safety on top of everything. And we're going to talk about two big ones, caching for speed and transactions for safety. So let's talk about performance for a second. Imagine your app needs to pull up the same user's profile like dozens of times. Hitting the database every single time? That is just incredibly slow and inefficient. So how do we make that faster? The answer, of course, is caching, and Hibernate has our back here. It comes with what's called a first-level cache, and it's on by default. This cache is tied to a single session or operation. So if you ask for the same user twice inside that one operation, it only goes to the database the first time. The second time, it just pulls it from this super fast cache. Now for even bigger wins, you can turn on the second level cache. This one is shared across your entire application. It's an absolute game changer for reducing database hits on data that everybody needs all the time. Okay, so that's speed. What about safety? How do we keep our data from getting corrupted? Well, that is the job of something called a transaction. A transaction is basically a protective bubble you put around a whole unit of work. The classic example is a bank transfer. You have to subtract money from one account and add it to another. A transaction makes sure that either both of those things succeed, or if one of them fails, the whole thing gets rolled back. The database is left exactly like it was before we started. No money vanishes. And this safety net is guaranteed by these four famous properties, known by the acronym ACID. So A is for atomicity. It's all or nothing. The whole transfer happens, or none of it does. C is for consistency, which just means the database is always left in a valid state, no rules are broken. I is for isolation. This is crucial. It means if two transfers are happening at the same time, they can't mess with each other's data. And D is for durability. Once a transaction is committed, it's permanent. It will survive a server crash, a power outage, whatever. That change is there to stay.
And there we have it. We've really covered the whole journey, haven't we? We started with the why, that tricky object relational mismatch, and moved to the how with those clean, modern annotations. We followed an object through its entire life cycle, from transient to removed, and we saw how these amazing features like caching and ACID transactions make our apps not just faster, but so much safer. You can think of Hibernate as providing the map, the vehicle, and the rules of the road for your data's journey. So now that you see the map, where will your data's journey begin?